Hi, I'm Ken Kiyono from Osaka University. Today, I'd like to give a talk about healthcare digital transformation using smart wearables. My current research field is biomedical engineering. So far, for about 20 years, I have studied and developed biosignal analysis methods, mainly for medical purpose. Recently, many types of wearable devices have been appeared on market. For instance, using a smart clothing, as shown in this figure. So using this, where we can easily measure biosignals such as heart rate and physical activity. Heart rate can be detected from the electrodes inside this underwear, and physical activity can be measured, can be assessed using the accelerometer included in this device. Here we call such devices smart wearables. For recent 5 years, I have studied application of such wearable devices, and I have developed the workplace wellness management system using wearable devices. The workplace wellness management system, called Smart Fit for Work, was implemented by Cravo Industries Limited, and it has been on the market already for 4 years. It has been used by many companies such as Toyota Motors, Siemens Corporation, and JFE Plant Engineering. Based on such experiences, I'd like to give a talk about healthcare digital transformation. So far, market growth of the wearable devices has been expected because it has been suggested that smart wearables can improve our health and quality of life. However, to make it possible, it is needed to develop and expand applications of smart wearables. To develop the applications, I would like to emphasize the importance of the digital transformation. In this case, the digital transformation means how we can generate valuable information from data. Here, I wrote to survive VUCA world. What this means? VUCA, B-U-C-A, is an acronym that stands for volatility, uncertainty, complexity, and ambiguity. The concept of VUCA was coined in the U.S. Army War College to describe the post-war world. VUCA became increasingly popular in business fields around the mid-2010s. As you know, we are now facing unsettled and unpredictable issues, for instance, related to the novel coronavirus made us aware that we are living in VUCA world. In addition, we also have issues related to super age society. I will explain about this. And extremely heat summer. We have to solve those problems. The point of my talk is that knowledge discovered from real-world data. Such knowledge would provide helpful and useful information to solve such problems. Here, I would like to briefly review social problems in Japan. Now, we Japanese are living in super-aged society and facing many social problems. When we estimate the percentage of the elderly population aged 65 and over, in Japan it was 29.1% at 2021. In Europe, it is expected to grow to almost 29% by 2050. It's not high, I think. Yeah. In Japan, it is expected to grow to almost 40% by 2050. Note that Japanese problems would be future problems in the world. The social insurance and the pension system is important for our society and our life. When we discuss the stability of the social security system, the basic question is how many working age people are available to finance one retired person. In 1960, it was 11 people. The life expectancy of female was 70 years old, and that of male was 65 years old. Now it is 2 people. The life expectancy of female is 88 years old, and that of male is 82 years old. As you can imagine, this is a very heavy situation. To reduce this heavy burden, retirement age rising will be required. But if we suppose the retirement age rising, we have to care age-related health problems because physical function decline with aging. This poster is a job advertisement. Okay? You can see McDonald's. This poster says, team would support elderly workers. Yes, such support will be required. To support elderly workers, the importance of workplace wellness management will increase. Actually, I have developed the workplace wellness management system using smart wearables. A conventional healthcare approach would focus on the health disease boundary to prevent disease. If you cross this line, you are most likely to get sick. Medical viewpoint would consider mainly this boundary. In contrast, wellness. Do you know wellness? Wellness means overall well-being. So the wellness care should support a wider range of everyday life. For the workplace safety and health management, an acceptable standard is set with a margin on the safety side. And the employer tries to keep the standard. This is the traditional approach. However, it is very difficult to determine the acceptable standard based on the empirical evidence. So I thought I would like to develop an effective workplace wellness management system using smart wearables. For about 20 years, I already said, I have developed biosignal analysis methods mainly for medical purpose. So I am very familiar with heart rate variability analysis. Heart rate variability means fluctuation of interbeat intervals. As you can see here, healthy heart rate variability shows large fluctuations in comparison with heart failure patient. Because we can measure heart rate and heart rate variability using wearable devices, you may consider medically oriented analysis methods and knowledge are applicable to workplace management. It would be applicable, but in my opinion, new methodologies are still required, especially for the workplace management. To achieve an effective workplace wellness management, I would like to propose some ideas based on my experiences. The first is a human-centered design of a cyber-physical system. In a cyber-physical system, real-world data are integrated and analyzed in a cloud computing system, where the physical space means real world, and cyberspace here means a computer network and cloud computing system. In our system, workers' data such as heart rate and physical activity are measured by IoT biosensors. In addition, weather information, including temperature and relative humidity, is obtained from sensor network of a weather forecasting company. By analyzing integrated dataset using AI and big data technologies, we try to find and solve real-world problems. In addition, it is possible, using this system, it is possible to provide real-time nowcasting of the worker's condition. The second is the personalized approach. This is about the analysis method. To assess physical condition of a worker in real time, we use mathematical modeling of an individual heart rate response using smart wearable and a cyber physical system. Available data are here: age, gender, occupation, heart rate, physical activity, including temperature and environmental temperature and humidity. Using these data, except for heart rate, we consider to predict the corresponding heart rate, like this. Here, this part represents the mathematical model. Although I don't want to go into the detail of the mathematical model, anyway, we can generate a mathematical model using a machine learning technique. Even a simple multivariate regression model Yes, even such model could provide a good prediction. Using such a model and the observed data, we predict the corresponding heart rate. Through this modeling, the smart wearable learns the characteristics of the individual. This plot shows the temporal profile of the predicted heart rate. In the next step, we compare the observed heart rate with the predicted one. If we observe a systematic deviation from the prediction, it would mean the occurrence of unusual situation. If the system detects such behavior, a warning will be sent to the worker and manager. Actually, it has been demonstrated this approach has good performance. In this actual example, at this timing, the system detected unusual increase of the heart rate and sent a warning. After that, this worker actually complained of poor physical condition and took a rest in the company infirmary bed. After a while, as you can see, this worker seemed to have recovered. This is an example of another worker. In this day, shown in the bottom panel, we can see clear difference between predicted orange solid line and observed heart rate, blue solid line. Actually, after work, this worker complained of poor physical condition and absent next day. Since abnormal deviation had already been seen from the day before, the early intervention was possible. But in reality, it could not be prevented. In cases such as infectious disease, like this, such changes like this could be seen. The third is the best model of a cat is several cats approach. The sentence, the best model of a cat is several cats, is a paraphrase from a review by famous mathematician Norbert Wiener. Do you know Wiener? He's a very famous mathematician. In the previously mentioned personalized approach, we used a mathematical model for the prediction of the heart rate response. It works good. I agree that such mathematical model could provide a good prediction or approximation when we deal with interpolation problems. I would like to explain this point. Okay, in this plot, blue dots represent the observed data. Yeah? So we can fit a model to the observed data. So the fitted model could provide a good prediction, like this. At this point, would be good prediction. However, when we deal with extrapolation problem, the, the prediction may be unfounded and maybe a big mistake. Because I'm sure this point, whether this point is good or not. Because this part corresponds to inexperienced range. Okay? To solve such extrapolation problems and inexperienced problems, it would be better not to use unfounded mathematical model. So we should observe the real cats. Now, as an example, we would like to discuss heat stress assessment problem for heat stroke prevention. Recently, we tend to have extraordinary hot summer, probably because of the effects of global warming. Rectal temperature. Do you know rectal temperature? Okay? One of the core body temperature. Although I don't want to explain that how to measure this. Anyway, the rectal temperature is a widely accepted heat strain index. Okay? So, however, it is impossible to measure the rectal temperature during work. Instead of the rectal temperature measurement, we may use a mathematical model with observable variables. Supposing extremely heat with a temperature with a temperature of 40 degrees of Celsius, the model is unfounded. Okay, we never experience such situation. Believing in the model may be dangerous. So instead of the model prediction, it is better to use the group mean heart rate of worker samples. Because the group mean heart rate, okay, the mean value of the heart rate is highly correlated with the group mean rectal temperature. This comes from statistical law. This method is very easy. It just calculates the mean heart rate of the worker group. If we estimate the group mean, variation among individuals are averaged out, disappeared. The important point is that the group mean heart rate in a same environment depends on exercise load and environmental stress. The environmental stress would mean the heat stress. This plot shows actual examples. This axis shows the exercise load. This exercise load was estimated by accelerometer. If we estimated the group mean heart rate under the condition of outside temperature was lower than 25 degrees of Celsius, it resulted in this blue solid line. The heart rate increased as the exercise load increased. Under the different condition of outside temperature was higher than 34 degrees of Celsius. It resulted in this red solid line. This increase represents the degree of the heat stress. So based on the actual observation, we can assess the heat stress. When outside temperature exceeds body temperature, that is, when the outside temperature exceeds 37 degrees of Celsius, the conventional standards would not be applicable because the standard was not based on any evidence. Even in such situations, this approach is applicable. Using this approach, we can get real-world evidence derived from real-world data. For the heat stress assessment, instead of the conventional wet bulb globe temperature, we can use smart wearables. Here I would like to briefly explain about the wet bulb globe temperature. It's called WBGT. The wet bulb globe temperature is defined using measurements of thermometers. And by using this equation, weighted averaging, this WBGT model is not the best model of a man. This approach has high applicability to VUCA environment. I here introduced the assessment methods, but achieving improved wellness and safety is more important. Using this approach, we can quantitatively estimate the risk. If there was some risk, we should introduce some improvement measures. After the introduction of the improvement measures, we can again estimate the risk, and we can evaluate the improvement measure efficiency. This cycle is important. This is the summary of my talk. To induce the big market growth, okay, it is needed to expand applications of smart wearables. I emphasized this point. Data can create valuable information. To create value from data, I proposed these approaches. These approaches cannot be done without smart wearables. So I think smart wearables has great potential. I would like to continue to demonstrate the great potential of smart clothing and smart wearables. Okay, that's all for today. Thank you for your kind attention.